Good day, my dear student friends. In this video session, let us learn how to derive the shape functions for one of the higher order element, one-dimensional quadratic element. Higher order elements are those whose order of the polynomial is greater than 1. That is, higher order elements consists of secondary nodes along with the primary nodes. Secondary nodes are nothing but mid-side nodes and the interior nodes, and the primary nodes are the corner nodes. If the secondary nodes are introduced, if the secondary nodes like mid-side nodes and the interior nodes are introduced along with the primary nodes, then into the element, then those elements are known as higher order elements. Okay, now here one of the higher order element we will consider and we will derive the shape function. Now let us derive the shape functions for one-dimensional quadratic element. Here let us consider a three-noded line element. It is a one-dimensional quadratic element. These node numbers I have numbered node number 1 here left side and node number 2 right side and node number 3 at the mid side, and the natural coordinate origin, it exists at the center, and here to the left zeta is -1, and these are the natural coordinate values. Zeta is +1 to the at node number 2, and node number 3 zeta is 0, that is the origin. To the left it is negative and to the right it is positive. Okay, now these three natural coordinate values we have, and now let us consider this 1D quadratic element having 3 nodes. Now we will use Lagrangian formula to determine the shape functions, 3 shape functions n1, n2 and n3. Using Lagrangian shape functions, we know that the formula Lk of zeta, that is since it is a one-dimensional element, the coordinate value we are using only x component, in only x component, that is zeta, and for 2D two-dimensional element we are using zeta and neta. Since it is a one-dimensional element, we will use only zeta. Now Lk of zeta, that is L is nothing but Lagrangian shape function, and K, it is the node number at which the shape function has to be determined of zeta, that is the coordinate. Okay, it is equal to, it is the product of this ratio. It is the product of this ratio from the limit I is equal to 1 to n. It is the range from I is equal to 1 to n. The product of this ratio will give the shape function at that particular node number, and here it is given by the ratio zeta minus zeta I divided by zeta k minus zeta I, and I is ranging from 1 to n, but I is not equal to k. I is not equal to k. Okay, let us proceed to the shape function derivation. Let us derive first shape function n1. Okay, n1 can be written as n1 is equal to L1 of zeta. Now n1 is that is the shape function at node 1, that has to be found out, and it is equal to L1 of zeta, that is Lagrangian shape function at node 1 of zeta. Okay, now at node 1 how do we find? That means here n1 if you are finding, then k will be equal to 1. Okay, and I should not be equal to 1. Okay, because I should not be equal to k according to the formula. Okay, now I will use this form ratio. Now I is equal to here 1, I is equal to 2 and 3. I is equal to 2 and 3 here, and k is equal to 1. Okay, now by using this formula zeta minus zeta I, that is zeta minus zeta 2 divided by zeta k minus zeta I, where k is what? 1, that is zeta 1 minus zeta 2. Okay, now into one more node is there, that is I is equal to 3. Next multiplied by zeta minus zeta 3 divided by zeta 1 minus zeta 3. Okay, where I is equal to 3, zeta 1, that is zeta k, where k is 1, zeta 1 minus zeta 3. Now let us substitute the natural coordinate values. We have, what is zeta 2? Zeta 2, that is at node 2 the zeta value is +1. I have substituted here. Next zeta 1 minus zeta 2, zeta 1 value is -1. You substitute here. Minus zeta 2 value is +1, -1. Okay, here you substitute. Okay, like this. Zeta 3 value I have substituted here 0, and zeta 1 value I have substituted -1, and zeta 3 again 0. Okay, like this you substitute all the natural coordinate values that already we have defined. Okay, in the sketch we have shown all those natural coordinate values in the sketch. These are the standard values we should refer, and next this product will give us zeta into zeta minus 1 divided by 2. Okay, zeta into zeta minus 1 divided by 2, that is n1. This is the shape function n1 at node 1 for 1D quadratic element. It is given by zeta into zeta minus 1 by 2. Okay, now come to n2. Shape function at node 2 can be found out by using again Lagrangian shape function formula, that is n2 is equal to, you can write L2 of zeta, where 2, that is k is equal to 2 and I will become 1 and 3. Okay, and now the n2 is equal to zeta minus zeta I, zeta minus zeta 1 I will use first, node number 1 zeta 1 divided by zeta 2 minus zeta 1, that is zeta k minus zeta I, where zeta 2 minus zeta 1, 2 is what, that is the k. Okay, zeta 2 minus zeta 1 into, next one more I is equal to 3 is the zeta minus zeta 3 divided by zeta 2 minus zeta 3. Like this you write. After that you substitute the values of the natural coordinate value zeta 1 as minus 1, zeta 3 as 0, and next zeta 2 plus 1, zeta 1 minus 1, next likewise zeta 3 0. Likewise all the natural coordinate values you substitute into this n2 equation. We will get zeta into zeta plus 1 by 2. Therefore we will get n2, we got zeta into zeta plus 1 divided by 2. That is the shape function at node 2. Now come to shape function at node 3. That is n3 is equal to, where you can write by using Lagrangian shape function, n3 is equal to L3 of zeta. Okay, that is at node 3, where L3 at node 3 you are finding the shape function, then k will become equal to 3 and I will become equal to 1 and 2. Okay, now n3 equals to zeta minus zeta 1. Okay, I will consider I is equal to 1 here, divided by zeta k minus zeta I, that is zeta k is zeta 3 minus zeta 1 into, next I will consider node number 2, zeta minus zeta 2 divided by zeta 3 minus zeta 2. After that you substitute the natural coordinate values into this equation for zeta 1, zeta 2 and zeta 3. If you substitute all the values, we will get the resulting n3 shape function. Okay, now just we will discuss here. Now here n3 we got zeta minus of minus 1 divided by plus 1, zeta minus 1 divided by minus 1. I will write this as 1 plus zeta, and this as minus of zeta minus 1 is 1 minus zeta. 1 plus zeta into 1 minus zeta, that is a plus b into a minus b. We will get 1 minus zeta square. n3 shape function n3 we got 1 minus zeta square. Likewise the three shape functions we have derived in natural coordinates, in terms of natural coordinates, that is in terms of zeta for one dimensional quadratic element, those are n1 is equal to zeta into zeta minus 1 by 2, and the variation of the shape function is n1 is equal to 1 at node 1. Just you should write, that is n1 is 1, and it is going to vary it is going to vary in a curve, that is quadratic curve like this. Okay, at node 2 and 3 n1 is 0, n1 is 1 at node 1, and this curve will represent zeta into zeta minus 1 by 2. This is the variation of the shape function n1. And n2 we got zeta into zeta plus 1 by 2, and the variation of the shape function is given in this sketch, that is n2 at node 2 it is 1, at node 3 and at node 1 it is 0, and n2 is 0. That is one of the first property of the shape function, and it varies quadratic. Okay, next n3 we got 1 minus zeta square, and it varies like this, the variation of the shape function given in this sketch, and n3 is equal to 1 at node 3, and this curve will represent 1 minus zeta square. And here the variation of these shape functions will be quadratic. Here it is not a linear, it is a quadratic. Okay, likewise you can derive the shape functions n1, n2 and n3 by using Lagrangian method of shape functions. And one more thing I want to discuss with you, that is, in the previous video we have derived the shape function for one dimensional linear element by using that polynomial function. Okay, now this derivation also we can derive the shape functions for 1D quadratic element by using that polynomial function also, by assuming, okay, that also you try, and you just compare with these two. You will get the same shape functions n1, n2 and n3. But this Lagrangian shape function method will become, it is very simple, and it is very here the steps involved will be less as compared to the polynomial function. Now if we consider, you have to assume n1 is equal to, for quadratic element, the shape function n1 can be assumed as a1 plus a2 zeta. This is for linear. For quadratic, plus you should go for one more coefficient, a3 zeta square, where order of the polynomial is 2. For quadratic element, order of the polynomial is always 2. For linear element, it is 1. Okay. Now in the previous video, we have derived the shape functions for 1D linear element by assuming the polynomial function a1 plus a2 zeta only, where order of the polynomial was 1. Now since we are deriving the shape function for one-dimensional quadratic element, the order of the polynomial you should use 2. Then let n1 is equal to, you should use a1 plus a2 zeta plus a3 zeta square. After that, you apply the conditions for 3 nodes, then you will get the 3 equations. Those 3 equations you solve for a1, a2, a3, and substitute back a1 and a2 and a3 into this equation. You will get n1. What is that? For first condition, if you want to apply, that is n1 is 1 at node 1 and zeta is minus 1. If you substitute n1 is 1 and zeta is minus 1, you will get one equation. And at node 2, zeta is plus 1 and n1 is 0, and if you substitute into this equation, you will get second equation. And at node 3, zeta is 0 and n1 is 0. If you substitute into this equation, you will get third equation. All those 3 equations you solve for a1, a2, a3 and substitute back into this equation, you will get n1. Likewise, n2 also you can find by assuming the same polynomial function. n2 is equal to a1 plus a2 zeta. Okay, sorry, now it is due to insufficient phone storage it is showing. Okay, now okay, now here n2 also can be found out by using the same method, that is a1 plus a2 zeta plus a3 zeta square. After that, you substitute the conditions for n2 at nodes 1, 2 and 3. At node 1, n2 is 0 and zeta is minus 1. If you substitute, you will get one equation. At node 2, n2 is 1 and zeta is plus 1. If you substitute, you will get second equation. At node 3, n2 is 0 and zeta is 0. If you substitute the third equation, you will get, then you will get after that, solving those 3 equations, you will get a1, a2, a3. By substituting back into this equation, you will get n2. Likewise, n3 also you can find out by using the same procedure, and if you compare, you will get the same, but little bit it will be lengthier, this method. But using Lagrangian shape function method, usually what you do, my dear students, higher order elements shape functions you derive by using Lagrangian method of shape functions formula, so that it will be easier. And it okay, now, and also you can verify the one of the property of the shape function, that is sum of the shape function is always equal to unity. If you get the sum of the shape functions of all these n1 plus n2 plus n3, you will get 1 only, that is you will get unity. n1 plus n2 plus n3 is equal to 1. Okay, and after that you can compare, we know that the sum of the shape function is always unity. You can derive this for n3, last one. We know already n1 plus n2 plus n3 is equal to 1. From this you can directly find out n3, because n1 n2 already you have derived. Then n3 you can find out. Now already it is been found n3. No need to use this Lagrangian shape function. Directly from the property of the shape function you can find n3. Once you know n1 and n2, n3 is equal to 1 minus n2 minus n3. Then n2 and 1 minus, okay, what is that? Okay, n1, we know that third property of the shape function, n1 plus n2 plus n3 is equal to 1. Okay, and from this n3 can be found out 1 minus n1 minus n2. Just you need to substitute the values of n1 and n2 which have been already determined, that is n3 equals to, you can find 1 minus n1 is zeta into zeta minus 1 divided by 2, and n2 is zeta into zeta plus 1 divided by 2. Then you will get n3 as 1 plus zeta into 1 minus zeta, that is 1 minus zeta square. Okay, like this also you can do. This is how you can derive the shape functions for the 1D quadratic element. It is very simple, my dear students. In the previous question papers, in one of the almost in previous question Visvesvaraya Technological University question papers, this derivation was asked for 8 to 10 marks. Okay, I hope you have understood. In the next video we will derive the shape functions for 1D cubic element. Thank you, take care, stay safe, stay healthy.